Okay, as we ran out of time in the last video, we were finding R45. Okay, so 1 over R45 is equal to 1 over R total, which is 2 ohms, minus 1 over R123, which is 4 ohms. So 1/2 minus 1/4, R45 is 1 over R45 is 1/2, so R45 is 2 ohms. I'm going to fill that in down here while I remember it. 2 ohms. So now that I have that, I can find my R4, right? Because somewhere over here, R4 and R5 are together. So 1 over R45 is equal to 1 over R4 plus 1 over R5. So 1 over R4 is equal to 1 over R45 minus 1 over R5. So 4/5 was 2 ohms. Wait, 1/2 minus 1/4 is 1/4, not 1/2. This is 4 ohms. Math is good. So this is 1 over 4 ohms minus 1 over 12. So this is the same as 3 over 12 minus 1 over 12. So 1 over R4 is equal to 2 over 12, or 1 over 6. So R4 is equal to 6 ohms. 6 ohms. Okay, and while I'm here, I may as well put in 5. It was 12 ohms. R3, 4, 5, or 1, 2, 3 was 2 ohms. 2, 3 was 2 ohms. Oops, get the sheet out. 3 was 6 ohms. 2 was 3 ohms, and 1 was 2 ohms. All right, so now we have all our R's, and we have all our totals. So now we look at our most simplified circuit, which is parallel, and in parallel, the voltages are the same. So V123 and V45 should be equal to V total. So this should be 8 volts, and this should be 8 volts. Okay, and so 4 divided by 8 will be 2 amps. 8 divided by 4, and 8 divided by 4 will be 2 amps. Now we step back, and in the step back, what was put together in this circuit was R1 was put together with R23. R1 and R23 are in series, and in series the current is the same. So the current through 1 and the current through 2, 3 should be equal to the current through 1, 2, 3. So this should be 2 amps, and this should be 2 amps. 2 times 2 is 4 volts. 2 times 2 is 4 volts. This is the one that has all the same numbers. Okay, we've now solved for that one. So now we step back one more time. And R23 replaced R2 and R3, which were in parallel with each other. And in parallel, the what's the same? The voltage is the same. So V2 should be equal to V3, should be equal to the V of what replaced them, V23. So this should be 4 volts, this should be 4 volts. So this should be 4 over 3 amps, and this should be 4 over 6, which reduces, of course, to 2 over 3 amps. One last one is 4/5. R45 replaced R4 and R5. They were connected in parallel, and in parallel the voltages are the same. So V4 should be equal to V5, should be equal to V45. This should be 8 volts. This should be 8 volts. 8 divided by 6 is 4/3 of an amp. 8 divided by 12 is 2/3 of an amp. And you are done. Doing your checking, nothing is bigger than 8. And nothing is bigger than 4. You're good to go. All right, next one is this guy. Okay, so what are we putting together first? Well, the current's leaving the power supply and flowing through R1. So in the end, it's going to be a series circuit. But when it gets to this junction, it splits. So these two branches are parallel. But in this branch, it splits again. So R34 is going to get joined first. Okay, so R1 R1 is going to stay here. R2 is going to stay here. This is going to be R3, 4. This is going to be R5. So R1 is still 6 ohms. R2 is still 12 ohms. R5 is still 6 ohms, and we need to find 3, 4. Okay, so we can do 1 over R3, 4 is equal to 1 over R3, 9 ohms, plus 1 over R4, 18 ohms, which is 3 over 18 ohms, or 1 over 6. So R3, 4 is equal to 6 ohms. All right. But still not complete series or parallel, but R3, 4, and R5 we can now put together. So in our next step, still leave R1 and R2 where they are, and this branch now becomes R3, 4, 5. So R1 is still 6 ohms, R2 is still 12 ohms, and R3, 4, 5 we can get by just adding 6 plus 6, 12 ohms. Still not pure series or pure parallel, but we're getting closer. We can now add the two pieces that are parallel. So we'll go down here so that in the end, here's my R1 and this guy. So R1, which is 6 ohms, and R2, 3, 4, 5, they're in parallel, so we have to add them. So 1 over R2, 3, 4, 5 will equal 1 over 12 plus 1 over 12, which is 2 over 12, or 1 over 6. So R2, 3, 4, 5 is equal to 6 ohms. So this guy is 6 ohms. And what was my total voltage? 20? So V total 20 volts. So we can now fill in our what we know. So we have 20 volts. Oh, when you take a look, 6 ohms and 6 ohms, our total should be 12 ohms. R1 was 6 ohms, R2 was 12 ohms. Oh, this one's going to have a ton of numbers the same as well. R3 is 9 ohms, R4, 18 ohms, R3, 4, 6 ohms, R5, 6 ohms, R3, 4, 5, 12 ohms, R2, 3, 4, 5, 6 ohms. Wow, talk about a lot of numbers that are the same. All right, in our most simplified circuit here, it is series, and in series the I's are the same. So I total should be equal to I1, should be equal to I2, 3, 4, 5. What is my I total? It's 20 over 12, which is 5 over 3. So it's, maybe I will leave it as 5 over 3. It might make my math life a little easier. So did I screw up? No. All right, and so this should be 5 over 3 as well, and the other one is this one all the way out here, 5 over 3. So, move over. 5 over 3 times 6 should give me a voltage of 10 here. And 5 over 3 over 6, give me a voltage of 10. All right, now we step backwards. R2, 3, 4, 5 replaced R2 and R3, 4, 5. They were in parallel, and in parallel the voltages is the same. So V3, 4, 5 and V2 should be the same as V2, 3, 4, 5. 10 over 12, that's 5 over 6 amps. And 10 over 12, that's 5 over 6 amps. All right, and then 3, 4, 5 replaced R3, 4, and R5. They're in series, and in series the current should be the same. So this should be 5, 6 amps. This should be 5, 6 amps. Multiply, this will be 5 volts. This will be 5 volts. 3 and 4 were connected in parallel, and in parallel the voltages are the same. So this should be 5 volts. This should be 5 volts. 5 over 9 amps. And 5 over 18 amps. And